Well, hi, good morning. Thanks so much for joining me here in my shop on May 2nd. Oh my gosh, it's another month. So, one of the things about both of these radios is that they have a lot of spread bands on their dials. Let me just whip one cabinet up here quickly. A lot of shortwave radios, the shortwave bands are really compressed. And it's pretty hard to know where you've tuned on a radio like that, but this one's different. This one, like if you look at the 31 meter band in the middle, it goes from 9.3 to 9.9. That whole band length is just 600 kilocycles. So, I mean, what I'm really trying to do is take advantage of this and get both these radios accurate enough on the dial that you can know what frequency you want to tune there and get there. So that should be possible with these radios. I'm sure they weren't designed so they wouldn't work right. A lot of effort probably went into getting the scales and everything correct so they could be accurate. So I've aligned both these radios. This one I did like a year or two ago, and this one I just did very recently. This one, because once it's out of the cabinet, you can't compare the pointer to the dial glass. You can't see it. You have to do something else. And for this radio, I wrote a bunch of values on the back of the panel here. And for this one, it comes with an index here and references to index numbers when you're doing the alignment. Both of these radios went through a pretty good alignment check, which I have here. And I sort of summarize the situation here. This is for this radio, and so that tells me the shortwave band, and the one that's not the actual band that's not spread so much. Yeah, it's pretty accurate, but the 19 meter band is off all the way across and quite a bit at the top end. So something went wrong with doing that. And likewise, the other radio, the alignment's actually a lot better. It could be because it wasn't me doing this. It came with this index and is designed to be aligned. The information all talks about that index there. I had a pretty good result considering the radio's been sitting around for a year. This one is really only this band that's out a significant amount. An amount worth doing something about. Maybe this last one too. So what am I to do? Am I just to repeat what I've already done? Won't I just end up in the same sort of bucket? Maybe I'll have a different band off from the ones that are off now. So I'm reticent to just go through the same process again for fear of just getting the same result. I want to do something that would be more precise. And I've been thinking about this for a couple of days, and the light switched on yesterday. I have a method now. I'm going to explain my method. Sometimes when I explain these things, I realize the problem with them, and it can't really be done. But what I can do is I can put this radio back in its cabinet, turn until the pointer is pointing at the proper frequency for alignment, make a note of what the local oscillator frequency actually is. Now, how would I know that? I will use my SDR radio. I will see where the local oscillator is on the frequency display, with the dial pointing at, let's say, on the AM band pointing at, say, 1400. The local oscillator is reading 1440. So I'll write that down, 1440. Take the radio out of the cabinet. After doing all the bands, take the radio out of the cabinet, monitoring the local oscillator, dial it up to, what did I say, 1440. Now I know the radio is pointing at 1400. I know that because of what I did previously. I then leave it there, and using the oscillator adjustment, change the 1440 to 1400. So in a sense, I'm using the local oscillator to key where the radio is actually aligned at. That's my method. Hey, I just explained it. It's holding water. So I'm going to try this. Maybe I'm going to try it on this radio. So This radio I recently fixed up. I've checked everything on it. I think it's in good shape. The only thing that could be out of sorts is the alignment here. This one, you know, probably I should go through and check some voltages and do some other stuff. So it's not quite ready. But this one's ready, and this one also has a lot of alignment problems. Probably because of the crazy grid I put up there. Probably it wasn't as accurate as it could have been. So I think that's the deal. Okay, so I'll do a little bit on camera so you can understand what I'm doing, and then I'm gonna complete it afterwards. But I gotta get things set up first. Good luck to me. So here's what I've done. I've just made a very simple spreadsheet here. So I've followed exactly the way the bands are, or the information shown on the trimming procedure, as they call it, the alignment procedure, so I don't get confused. If you're hearing some bells ringing, that's my cat Shadow ringing her bell there. So down here I have the frequencies at which the alignment is supposed to be performed. And what I will do is I will tune the radio, for instance, to 6 megahertz. At 6 megahertz, the local oscillator should be running at 6.455, but mine is tuned a little off, so it's 457. And this is calculated. It's just adding 0.457 to this number. It gives you these. So I've done this one, the broadcast one here. I dialed in 600 kilohertz. The local oscillator should be at 1.057. It's at 1.053. Now how do I know it's at 1.053? This is my SDR. I'll show you in a moment how it's picking the signal up from the radio, but it's picking up the local oscillator from the radio. Now it's hard to pick off with all that stuff on there, but if I vary the tuning a little bit, the local oscillator will become apparent. There it is. You can see it moving back and forth there. So what I would do, what I've done, is I would tune this to one of the key frequencies, 1500 kilohertz, right there. And I would note the frequency right here. If I'm trying to click my SDR, there we are. So the red line here on the SDR indicates where the SDR radio is actually tuned, and that just helps me resolve the frequency here because it'll be written up here. So we get 1892. Let me just double check everything. Now the radio is tuned to 1500. I'm making sure there's no parallax error when I do that. So at 1500 we get 1892. Now if we go back to our spreadsheet here, 1500, 1.892. I'm going to continue this process, collecting these numbers. Then I will use this these values. I will tune the radio such that the local oscillator is once again at this frequency. When I do that, I'll know the radio is tuned. Actually, the front dial is indicating 600 kilohertz, and I will then adjust this to the correct frequency, which is this one right here. And then I have to repeat the other alignment elements, the antenna and the intermediate stage, to match the final resolution here. So it's going to take quite a while. Yeah, that's right. And of course, I have to do all this first. I have to do this actual column first, and then remove the chassis and get it ready for the alignment effort. So, holy smokes, let's go look at the radio here. So through the magic of video, I've stuck a screen on a screen. So when you're looking at the SDR here, it's just easy to see while fooling with this for me when I'm doing this work. Okay, well, I'm going to continue on now. Why don't we do one more? We'll do the 1500. We'll do this one here. 600. Okay, you can see where the local oscillator has ended up. So it's a little hard to see it on the screen there, but I can just click on it, and then I can just read the number, 1049. 1049. So it's 1049. I got 1053 here last time. How did I get two different numbers? It could just be, you know, the width of the pointer can be enough to set all this off. The radio is closely aligned except for one band, so I shouldn't expect too much adjustment here through any of this. Let me just double check this again because, yeah. So I'm going to zoom in on this and see if we aren't right on. Yeah, it's pretty much dead on. This is the local oscillator of the radio. And now I'm going to fiddle with the tuning a bit and kind of move the tuning, the width of the dial thing a little bit. This would, you know, this is the range of mistuning that could happen. That's about it there. Oh, it's almost nothing, isn't it? It's almost nothing. So I would give that to me it looks exactly correct now. There's a parallax on the camera view, so I'm positioning my eye very carefully. So what do we get? We're a little different now. Okay, let's just fix this here. So I would say that's where it is, 1050. 1050 on the spreadsheet last time around. 1053. How did I? Well, maybe I was really quick when I did this first one. So this should be 1050. 10.050. So what that means is later when I tune the radio, make the local oscillator operate at 10.050, the radio will be tuned to 0.6 or 600 kilohertz. Okay, so I think I know what I'm doing, which means I can go ahead and I will complete all this. It's quite a bit of number gathering here. Okay, let's go to the next band here. So radio's receiving something, but its antenna is nothing more than the signal generator. It's not the best antenna, but it's picking up some kind of noise. Okay, the proper tuning setting here is 6 megahertz. Right there. So 6 megahertz dead on. Okay, and what's the local oscillator? Oh, I gotta go up to 6 megahertz. Let's shrink it a little bit. Okay. So there's something way out on the left there. My assumption was the local oscillator is running above the target frequency, but it may not be. So let's tune the radio and find out. Yeah, that's the local oscillator there. It's below. Means my spreadsheet calculation is wrong. Okay, so let me tune this radio properly. Right on the 6, and the frequency of the local oscillator is actually 5802. 5802. I'm going to write that on the spreadsheet here. 585.802. So it looks like the local oscillator is above on the broadcast band, which it almost has to be above. But on the shortwave bands, they can put it below or above. There's benefits and detriments to both choices. So these guys look like they have it below. So I'm going to change this number here from plus to a minus. Well, okay, something terribly gone wrong here. 5.802 when it should be 5.5 if it's below. Well, something's gone totally wrong. Totally wrong. Totally wrong. Totally wrong. So we're at the lowest end of the band, and if it's above, it's going to be up around 6.4, 6.45, 6.457. And if we look at 6.4, look at that. It's not on the screen here. So what is this? Okay, let's go this way. We'll find another. There's the other signal. Now, did you see something there? These other signals moving? Well, all I'm doing is changing the display of the SDR. That, it's the first time I've noticed this. The SDR has a lot of ghost signals in it. A lot. And I think they're really showing up by doing this. Okay, so we ignore all the other ghosty signals and just pay attention to this one. Okay, and that one, this is the local oscillator here. That one is at, I have to change my calculation, 6.452. 6.452. 6.452. I'm going to change the calculation here back to what it was. We're going to add local oscillator frequency. There, now this, there we are. So it should be at 457. It's at 452. So it's out by 5 kilohertz. That's half the bandwidth of a international broadcast station. That's really close. I can get it closer. And we'll do one more, and then I'll just carry on my own. We'll do this one. So we'll tune up to 9.6, and we'll expect it to be 10.57. 10.057. We'll see what it actually is. 9.6. Okay, I'm going to change up here to 9. 9.6 is going to be right around here somewhere. That's interesting. I'm going to tune the radio and see. That's really interesting. Now, this is either a real signal at 9.450 coming out of the radio, or it's an artifact of the SDR. Okay, so one of the hints here is, let's see, I am tuning the radio up in frequency, and that thing is going down. That doesn't make sense. So I think that's nonsense. I think it's nonsense. You have to, I found when I'm using the SDR, and I'm using the very cheap RTL SDRs, okay, they're not high quality SDR radios, they're cheap, and they have a lot of problems. They have a lot of problems. So 9.6 is where we're going. The radio got quiet. Okay, get the 9.6 debate going on again. 8.5, 8.75, 9, 9.25, 9.5, 9.75. Well, there's a huge gap to 100. It should actually be a smaller gap. So my guess is things, as I mentioned before, things go wild at the end of the capacitor. So where's 9.6? I have to guess it. I really... Well, following the pattern is completely the same all the way up to here. So this has to be 9.75, not 9.6. 9.6 is then going to be about there. That's about the best I can do. Now, I mean, this is not a band spread band, so the precision, you can't be that precise. Try to be as accurate as possible, but not precise. Okay, so there's the local oscillator on the SDR. And if we check its frequency, we'll find out it's 9.886. Does that make sense? 9.2, 9.8? No, 9.6. That does not make sense. If we're at 9, if we're tuned to 9.6, then we'd imagine this to be up over a million. Is it over here off the screen? Is there another line? Well, where did this one come from? There is no other line. It's below. Here we go again. No, 9.6 is where I have the radio tuned. Why is there something there? What's going on here? It seems like it doesn't matter what I do. Everything becomes curious and weird. Okay, so once again, at 9.6, if the oscillator's above, then that's just above 10. Just above 10. You know what? Maybe 10. How much above 10? Because it's barely on the screen. Barely above 10. Well, we should see it here, but I'm going to slide this even further. Wow, not there. It's here. Okay, let's do the up-down test. I'm going to tune the radio frequency up, and we'll see which one of these goes up. So that one's moving. Okay, so that's got to be the local oscillator there. Wow, okay, and put the radio back on what I think is 9.6. Now, to bear in mind, I did the alignment differently. I assumed this was 9.6. Bad assumption. This is 9.6. As close as I'm ever going to get to 9.6. So what do we get this time? The whole display shifted a little bit. 9.863. So the radio is not tuned to 9.6 by any means. No, that's right. I did this wrong. Right. Just carry on, Jim. Don't overthink it. 9863. 9863. So we go 9863. So you see how far out that is. It's way out. Interesting. So you're supposed to have done this, do this, but then you're doing this again. If I look at the actual sheet here, what exactly is the difference? So the first time through we're doing oscillators, and the next time through on the shortwave band we're doing RF coils. So oscillator of the, so the first thing you do is you're setting the sort of doing I guess a general setting. I can't even say that. Whatever you do in this band in setting the oscillator affects all the rest of them. This band being the shortwave band. That's what I think is happening here. There's no reason to do these again. I haven't changed the radio at all. So we're going to jump up now to band 13. Wasn't I going to do this not on camera? I just can't trust whatever I say. So 13's way up here. The upper frequency on the chart is 21. Dial in 21. Okay, that would be 21. We gotta look at what's happened on the SDR here. 21. That's a weird way of getting there. 21. So if the oscillator is above, it's 21.4. 21.4. It's right in here. I don't see anything. If the oscillator is below, it would be 21 minus, 500 basically. So it would be 20.5. 20.5. 20.5. Oh, there it is. Right there. Double check to make sure it is the oscillator. I will turn the radio tuning upwards, and it goes up. So yeah, I don't doubt for a minute. That's the local oscillator. I set this very carefully back on 6 megahertz, and we will now take the measurement here. How do I get these funny numbers out here? Let me get rid of these. Okay, I'm just putting the red line right on top. 20.529. 20.529. 20.529. 20.529, and I had it again. I think this is on the other side. I'm going to continue just taking the measurements, and then afterwards I'll consider what it's telling me about where the local oscillator is, and I'll adjust these calculations. It doesn't really matter, actually. It doesn't actually matter what I write in this column. It's what eventually I do in this one, adjusted, when I go to make the adjustments. Okay, so next one's done at 22 megahertz. 22. Let's go there. Right there. Oscillator went off the screen here. Is that it there? Right there. Okay, so my calculation's way off. I will again tune the radio up in frequency, and it goes up in frequency. And I am tuned to 22. So if it's below, it would be 21.5. And there it is, 21.4 something. So it's below. And I'll make the exact measurement here. 21.423. 21.423. 21.423. Okay, next band 11.8. 11.8 on the next band. So that's this band. 11.8 is kind of in the middle. Right there. Let's see. Did it show up? Oops. 11.8 is right here. So if it's below, it's way over here. That might be it. No, I doubt it. Maybe it's above. Oh, there it is. Up here. Okay, I will tune the radio upwards. And it goes upwards. Okay, put this back on 11.8. 11.8. Actual number we're getting here looks like 12,250 to me. 12,250, 12,251, 12,251. If you can read the numbers there. I expected 12,257, got 12,251. So that's good. Good and close. That means the oscillator's above here. The next one is done at 15.3. 15.3. Some of the mistakes I've made while working on this radio is I started looking in the wrong column for the line across. If I have a line up, I can get over here, and I should be over here. I make that mistake in the middle of the alignment process and not know it. You end up with a bad result. You're scratching your head what went wrong. 15.3. We'll go hunt down the local oscillator now. 15.3. Okay, so SDR starts having trouble with frequencies up in this range. I'm going to shrink the display a little bit. And we see something right here. We've tuned to 15.3. We would expect it to be 15.7 or 14 something. There's nothing anywhere around there. Okay, we'll tune the radio up in frequency, and that goes up. And the thing way over on the right there. It's actually a stronger thing over on the right. On the left. Okay, so if we go back to 15.3, I think to take off roughly 500 to get 14.8 something. 14.8 something. And if you add it, you're way up here. Way up here. Where'd the other one go? Move this over. Is this the local oscillator? I think it is. $14,731. Okay, I'm going to put that in there. 14,731. There, I've changed the tone to quiet the radio down a bit. So if you look here, you'll see my earlier calculation with it above is 15,751, and here it's actually turned out to be 14, almost 751. So if you take the local oscillator at 455, you're going to move it. You're going to move twice that space if you go from above to below. So it's almost a megahertz. So you'd expect these numbers to be 900 kilohertz apart, 910 in fact. They're about a megahertz apart. So something's not right. Okay, we'll do the last band. 17.8 is the frequency we're heading for. 17.8. Let's get up here first. 17.8. So we're going to tune here. Local oscillator, if it's above, it's going to be up in this area. And if it's below, it's going to be down around here. Down around here. Okay. 17.8. Oscillator showing up. Yeah, I guess that's it there. 17.8. Okay. Take the frequency of it. So yeah, there's no way this could be done back in the day, when this radio was new. Nobody had this kind of, nobody had the internet, computers, SDR radios, and frequency displays, and all this kind of stuff. Man, it must have been almost impossible to get these radios properly tuned up. It really must have been tough, because even the instruments they were using were uncalibrated. It's a really tough job. The normal way of doing it with any precision would be to use known radio stations on known frequencies. It's the only way you could really accurately align one of these guys. 17,340. 17,340. Well, so I'm going to stop for a bit, consider what I've done here, look at these numbers, and come up with a target value here, and then an adjusted value over here. Change this to target. What do you mean by that, target and adjusted? Maybe adjusted is just a yes and no thing. Okay, yeah, I'm going to stop and ponder for a bit here. Yeah, I was just stepping out of my shop when I realized I never showed you how I'm picking up the local oscillator. It's not a big trick involved. So I've laid that loop of wire. It's just three turns of wire, random size. It's just something I have. I grabbed it, and these are the connections to the antenna input on the SDR radio. The antenna input's there, and the radio, I don't know if you can see it, it's down here. I moved it recently. It's right here. That's the kind of radio that we're listening to. Whole thing right there. Okay, we're not really listening to it. That's the kind of radio that we're observing the frequencies from. So I have found most radios have a powerful local oscillator leaking out of them, and you can pick it up quite easily. With an SDR radio. Just wanted to show you that, and I'm going to go ponder. Okay, next thing I want to do is verify the IF frequency, and I think if I just jam in, I got this hooked up to the antenna. Yes, I do. If I just jam in the IF frequency here, we should hear it. Hello. Where is it? Maybe that's a little odd. Wow, that's so I have the output of the signal generator right on the antenna. Wow, that's hard to believe. Let's just try another. Well, the band shouldn't matter. It's way off. 445. I thought I had it up above 455. What's the story here? What is the story? Let me set the SDR down in the IF range here. And the IF range is right in here. I'm going to try to expand that. So 450. What exactly we will see here on the SDR, I'm not so sure. Maybe nothing. Okay, let's move this around again. So I'm piling a pretty strong signal into the radio. I wonder if that's why it's showing up in so many places. Okay, so that's off by a factor of 10. 1/10. Now we can't hear it at all. This is a bit of an odd deal. I think when you have the signal generator hooked up to the antenna, it's pretty hard to beat that for a way to jam an IF signal into the radio. Let's find another way here. Let's just make sure what we've done. It's definitely there. Yeah, it's not we anyway, it's me. I'm the one making the mistakes. You're innocent. You're just watching. It's not even a mistake, is it? Well, what am I going to do with this now? I'm going to put it on the coil, a silly coil. Oh, it's not a very good view, is it? With that SDR there. There's my sniffy coil. What am I hoping to find here? Hoping to find the 455. Let's go right around this tube here. And I'm kind of just shooting in the dark at this point. Back up on full strength. I'm not hearing it at all now. Give it more strength. Where'd it go? Well, I guess blasting it in this way is not really working. Let me try this one. So what I'm trying to do is prove what the frequency is in the IF. And I'm proving nothing here. So these are metal cans. I can't imagine going over that. It's going to help. If we put it near the capacitor here, which I think might disturb the radio a bit. Okay, so that's probably disturbing things, but let's try it. Well, it's certainly visible on the SDR now. So we should hear it come out of the speaker as I cross the IF frequency, like we did before. There's nothing. It really is kind of odd. Nothing at all. So another possible tube, maybe this guy up in this area. Let's see what happens here. Something funny going on here. This just shouldn't be like this. Try some more direct approaches here. Ground the signal generator. Put this into the AM loop antenna input. Goodness knows why. Because I'm kind of desperate for making this do something. There it is. 445. So just listening to the ABC operate there. Off. And I thought I straightened this guy out. Well, I didn't. Okay, let's turn off the set here for a second. The situation is now I have the information I need to correct the alignment with the chassis out. I've also discovered the IF isn't particularly well aligned. Maybe that was part of the rubber mallet effect. Maybe I rubber malleted the IF out of shape. It needs to be adjusted again. And because we really shouldn't be trying to make this thing work precisely, correctly with the IF off. Okay, I know what I gotta do next. Okay, I'm about ready to go here. Let's fire up the radio. I have a capacitor installed on the grid of the mixer tube as instructed in the alignment instructions. Got my signal generator, which you can't quite see, set to 455. I'm really at a loss for how this got out of whack like this. Okay, the volume, there we go. That sounds like it's dead on. Okay, so I do have the meter hooked up here, do I not? We're getting, a tiny voltage here. There we are. 15 volt scale getting 3 volts. Now what I'm going to do is I'm going to vary the frequency. You know what, I can't handle the camera situation, so just watch the meter. Here. Where does it want to go up to? Well, it's where I thought it was, 458. What's happening here? Is that capacitor affecting it? Get 458 this way, and 440 something the other way. That's disturbing. That's disturbing. I mean, who's correct here? Who's got it right? Now what should I try? If I can vary this connection a bit, that might, if the variation affects the radio, then maybe that's a hint that the whole connection is affecting the radio. Let's start by extending this with another capacitor. Didn't do anything. Sounds exactly the same. Let me just check here. That's the maximum right there. So what are we supposed to think now? I got two measurements here. How can we determine if this is throwing it off? I'm following the instructions. You wouldn't think it would throw it off. I'm on grid 3. Grid 3. Let's just double check that. 6BE6. 6BE6. So grid 3 is on pin 7. That's where I'm connected. This is a 0.1. This is a 0.01. Suppose adding an additional 0.01 is not much of a difference. Maybe my difference technique here didn't really highlight a change. What I'm mumbling about is hooking up this capacitor, causing a shift in the way the radio is operating. Or what was wrong with the other method I used? The other method I used, the signal generator was just connected to the antenna. Let's repeat that. I'm going to get this out of here. Okay, and we'll just go on an antenna here. Doesn't like coming through. Or is it somewhere else now? So this is the shortwave antenna. Well, let's find out if it's somewhere else. I'm going to boost this up. Go looking for it. my signal generator is jumpy. There, we got it. Well, this is really strongly suggesting that how did I get some other frequency here? So there's a heterodyne tone in there. Let's see if we can tune it out. Yeah. Wait a minute. Should be able to tune that right out. Not. What's going on here? Oh, this is bad with a capital B. Now you know what it is? I've got a huge signal coming at the radio, and it's probably overloading the first two. That's probably what's happening, and that's causing a bunch of harmonics. And goodness knows what the radio does with all those harmonics in its mixer tube. So have I been listening to the IF, or what have I been listening to? Frequency is right around here. Oh my gosh, this shouldn't happen. Shouldn't be changing bands and having the... because I have the IF shoved in through the antenna right now. On the 49 meter band. No. We're on the broadcast band. Okay, nonsense gone. Wickedness. Okay, so this is having no effect now, which is what you would expect. And just basically, oh, hey, camera, what's with you? Why all that nonsense on the broadcast band? Let's just keep going. Since surprises come everywhere. No nonsense on any of these other bands. But if I go to the broadcast band, first of all, we hear a lot of stuff. The antenna amounts to nothing. It's just open wires. Some of that could be coming here though. Some of that noise we're hearing, because this is right on the grid. But what's with this? Tuning effect. So what could be happening is the radio's receiving stuff. It's getting into the IF along with the tone you're hearing, and then there's heterodyning going on. Let me take the tone off the signal generator. It's still there. Okay, I'm going to just tune the radio and make this maximum here. No, it doesn't make sense, does it? It's 455. This shouldn't affect it. Yeah, this shouldn't affect this guy. Well, not so true. If you tune in a second signal, you get a second output from the IF. You get a little more voltage. You get a little more negative there. What we really want to do, I don't know. I really want to go have a sandwich. Okay, I'm watching the meter. I would say that is the max. There it is again, 458. When it's on the broadcast band with the funny business. We go off the broadcast band, funny business gone, and watch this meter again. And I'm going to put the tone back on. And we'll just right where the heterodyne zeroes out pretty well. It's a little hard to see such a small amount, but and the number is it's same thing again, 455. I'm never getting back to this 448 thing. I don't know what that was. That was an anomaly. So or was it? I mean, I still have this hooked up here. So if we remove this, and then try to get the signal to go into the radio without any actual connection. The best way is to make a little loop antenna here and shove it in the back of the radio close to where the oscillator coils are. So these are the oscillator coils right here. Why close to the oscillator coils? That doesn't actually make sense. You want it close to the antenna coils. Jim, let's put it here. Okay, it's kind of wrapped right around the antenna coils. Okay, leave this here. So, you know, I don't hear it. Okay, very low power. Okay, where's this peak? Right there. Same number. It's all pretty convincing that, well, how did I get 448 there for a while? Okay, so now that's a little odd. I changed to the broadcast band. I still hear it barely though. It's the same spot. I guess maybe I've switched, you know, the way I've got this coil back here. Maybe it's just affecting the short wave band better than the broadcast band. Doesn't make a lot of sense. Just hoop it up. Nope. Peak it using the ABC meter. My signal generator's a little jumpy on the control, and there it is again. 458. 458. I should take this capacitor out of here. Can I just pull it out? Yes. Didn't seem to make any difference. Watch the meter. Tune. I mean, you wouldn't expect it. There we go. Down. And if it made a difference, it's a micro difference. It's minimal. Okay, so you know where I'm at now. I'm at the point where I know the IF frequency in this radio is 458.0, I think is really where it is. 458. I'll make my calculations based on 458. And we'll tune the radio with a 458 IF in it. And ooh, I got a lovely signal there. Watch my meter. Right over. It's all proving the same thing. It is tuned to that one frequency. Okay, I don't know where the 448 came from. Son of a gun. Yeah. Okay, so I'm kind of losing my mind here. That's it for today. Tomorrow I will pick up with doing a very careful job of the rest of the alignment based on the information I collected earlier on the sheet, on my spreadsheet, and try to align this thing right on the money. We'll try. Thanks a lot for watching.